Oh, you're starting here. Can we start now to get an early start? Now we're gonna wait a couple minutes, see if anyone else shows up, while I finish drawing the problem too. By the way, there were no slides for yesterday's video, is that correct? Yeah, there was no slides. There are 6 watching the stream, started 6 minutes ago. Yeah, whatever. Is there a discussion question today? I do not think so, no. Is there a slideshow? Not really, it's review. However, we are going to do similar figures, so if you want to pull up the similar figure slideshow from before, it looks like this. You can look at that, but I'm going to draw everything anyways. What am I drawing? I'm drawing the first problem. 8 and 8. This is good. Oh, Porter's just talking. So, call this 9 feet. And let's call this 3 feet. Let's call this 5 feet. Let's call this 2 feet. Let's call this. Let's see. Are we doing the doc? We will after I talk about similar figures, which is going to be very similar to how you answer the questions in the doc anyways, could solve proportions and setting up proportions. Today we are going to be looking at similar figures and proportions and how they relate. Yeah, we're going to do similar figures real quick. It is not difficult. It's the same stuff you've been doing. And the practice today is going to be a review on solving things using proportions or whatever method that you wanted. So today's objectives are solve proportions with similar figures, and that's the first thing we're going to do. Our second thing we're going to do is some proportion word problem review, and I'm looking that you have a test on Friday on proportions and ratios. So that's what we're looking at today. Again, I'll give you another minute for someone else to join if they want to, and then start over. But it's not too difficult today. It is just proportion work, so it's going to be setting things up in the form of fraction equals that fraction, then cross multiplying. A math test, yes, a math test on Friday. And we'll spend the rest of the week reviewing. And that includes today. So your word problems and stuff like that. This is your assignment for today, is these word problems. They're all done by setting up proportions or by scaling or unit rate or however you so choose you wanted to do them. But the chapter was pretty much just, hey, here's what a ratio is, and here's a whole bunch of different ways to solve problems using them. And at this point, you can use any method that we discussed in class. Sometimes they'll be easier to do things like scaling or making a table, while others it'll be easier to just find unit rates, and while others it'll be easier to just make a proportion and solve. So before we do that, I will repeat our objectives. We're going to solve proportions with similar figures, and we're going to talk about what similar figures are and how proportions relate to them. Then you're going to work on our proportion word problem review, which is your independent work for today, and I will hang on to do some if you guys have questions. And then I want you to keep in mind that we are going to be having a test Friday on proportions and ratios. We will go over problems, but first we're going to look at similar figures. Yes, we will go over them, but first we're going to look at similar figures. We're going to take notes on similar figures first. So first, let's decide what a similar figure is. So first we have a definition of similar figure. A similar figure is a shape. It's actually two shapes or more that have the same shape so they have the same angles and stuff like that. In this case, angles. But different sizes. So we have different side lengths. So it's two or more shapes with the same size, or the same size angles, right? So it's the same shape, but it has different side lengths. So for example, you could have boom, a square, and then you could also have, we're going to compare that to, how do I want to do this? A square that's larger. So you have a square and another square. These are similar shapes. They have the same angle measurements. This is a 90-degree angle, this is a 90-degree angle, this is a 90-degree angle, this is a 90-degree angle. Those are 90-degree angles. This side is equivalent to this side, which is equivalent to this side, which is equivalent to this side. And this side here is equivalent to this side here, which is equivalent to this side here, which is equivalent to this side here. So they're both squares. They're just different size squares. They are similar shapes. If they are similar shapes, the other thing you know about similar shapes is your key for today. This is your star. corresponding sides are proportional. So in your thing here, if this was the side length of 1, then all these would be the side length of 1, and this was the side length of 2, all those would be the side length of 2. Then you can set up a proportion based on the sides. This side here, right, corresponds with this side here. So I can write them as a proportion of 1 over 2. This side here corresponds with this side here. So I can write them as a proportion of, again, this is 1 and this is 2, of 1 over 2. And I know these are equal. And that's going to be true with all the sides. If you follow along, it's in this PowerPoint right here, which is the proportional reasoning one. So I just did a different shape here. I'll do this shape in a second. But you can follow along with the notes, but you can take them too. It's not difficult. You just got to remember, hey, what a similar figure is, and note that once it's similar, once you've established that they're similar figures, you know sides are proportional. So here you have 1 over 2 is equal to 1 over 2. Now the one that was in your book, or not the book, it's in a different layer, isn't it? The one that was in your notes, it looks like, if I can draw it, I gave you a shape kind of like this compared to a bigger version of the same shape. I am not the greatest at drawing with the stylus yet. But here it said that this was 4, this length here was 1, this length was 5, and this length was 6. This length is 8, this length is 2, this length is 10, and this length is 12. It is telling you that these are similar figures, which means corresponding sides are proportional. So 4, this side here, on this shape here is an 8. You see how they line up? Those are the corresponding sides. So I know the fraction 4/8, or the ratio of 4/8, is going to be equal to, and then you can say, let's pick this one here. We have this length here is 1, here it's 2. 1 over 2, which is a true statement, right? 4/8 is the same thing as 1/2. And then that's true for all the sides too, though. You have this one here, which is 5, and this one here, which is 10. So that's also 5/10. And that's true for the last one, which is 6/12. They're all the same ratio because all the sides are proportional. Which means if I had to figure out a missing side, like if I didn't know this, I can. I know this proportion right here because of the corresponding sides, and I can solve for x. And to do that, you do 2 times 4 gives you 8. 1 times x gives you 1x. 8 equals x. This side being x equals 8. So you can figure that out using your proportional relationship. The problem I drew here is another one I want to look at. Deals with similar figures. In here, I did the best I could. We have the side of a street here, the best I could, and we have a lamppost. And the lamppost we know is 9 feet tall. The lamppost is casting a shadow that is 3 feet tall. And at the same time, we have a sign here, and we don't know how tall the sign is, but we know the shadow that the sign casts is 2 feet long. With that, you could think of this as, hey, here's a triangle, right? And here's a triangle. And they are similar figures. They are proportional. So the sides are proportional to it. So what you can do is you can set up a proportion to solve the height of this signpost. Here my lamppost is 9 feet, and its shadow is 3 feet. So there's a ratio of 9 to 3. Keep in mind, this here is your lamppost, and this here is your shadow. When you set up the proportion, you need to keep like things together. Like this is an actual physical object, so this sign here has to be the actual physical object. So we're going to put the sign's height on top, and then this is a shadow, and this is also a shadow. So we want the shadows on the bottom. So here our shadow is 2. We don't know the length of the sign. Once you set up the proportion, if I get rid of the words, it looks like this. You can cross multiply to solve. So 3x is equal to 9 times 2, which is, I'm double checking my face isn't in the way. No, I got plenty of room. Which is equal to 18 equals 3x. Divide that by 3, divide that by 3, you get x equals 6. So we know that the height of this sign, or x, is equal to 6 feet. And you can solve that through using proportions. Another way to look at this is if you want to measure the height of a building or something, you can do it by its shadows and something relative to you. Should you take notes on this, again, we're following right here. This is what you need to know. Similar figures, same shape, different size, corresponding sides are equal. So you know the 4 and the 8 is equal to the 1 and the 2. Right? And it goes in there. So if you want to follow along with that, currently Eli is the only one looking at it, you can. We know they are proportional because I said it was the same time of day, and the sun is going to cast the same type of shadow in the same location each day. So I know they are proportional to that. And that's going to be true for same locations, at least during the same time of day. So if they are right next to each other, the different angle that the sun is hitting these two signs is so small that it's not going to make a difference. Now, if you did this compared to like different cities, like one in the northern hemisphere and one in the southern hemisphere, then yeah, they're not going to be proportional. In fact, the reason they're not proportional is actually one of the arguments that early mathematicians and scholars knew that the Earth was round, is because they weren't proportional at different lengths. So like it was like in Rome, the building cast a shadow this much, and then in Alexandria and Egypt, the shadow was different. So they knew, hey, if the shadows are different, then the Earth actually has to be round in order to do that. We're going to, once we finish, if there's any other questions about similar figures, it's really just a definition. Right? So if you know the definition of similar figures, hey, they're two or more shapes, same shape, different sides, and corresponding sides are proportional. You can set up proportions with them and find the unknown sides. It was something that I wanted to go over earlier that we kind of lost track of time into it, so I saved it till the end of the chapter. There is no practice on similar figures unless you want to, go out and find it on your own. I actually don't even think the book talks about it, but it's a good place to talk about it, so I did. For the last slide, what about the sides with nothing? Well, that last slide, you figure them out. It doesn't matter about those slides, actually, because you need to use trig to find those ones. Here, I'm just going to start a new one. The last slide gives you two triangles. It says this is 3, this is x, this is 12, This is 20. These sides I don't really care about because I have enough to find x. Can you find the lengths of these sides through some trigonometry? Possibly. Not really. I think you need to know more information in order to find those, such as at least one angle measurement here. Then you can probably figure them out. But if it's just asking for this, you set it up as a proportion. So you see this 12 here. 12 corresponds with 3. So 12 and 3 line up. 20 here corresponds with the 12 because it's the same shape, and it corresponds with x over there. And then you can solve for it just using your proportion stuff. So 20 times 3 and 12 times x. Solve for x, and you get 5. So that is length of 5. And again, these sides you don't need in order to figure out x. It gives you a relationship between two corresponding sides, and it gives you another value and an unknown. That's enough information for you to solve for x. With that, again, you are planning on having a test Friday. We're going to try our best to have a math test online. It's not as great as I like it because I don't get to see all the work that you put in, but I think it's fairly well adapted for you to give me enough. With that, your review for today are the word problems. So you're going to be doing proportion, ratio, however you want to call it, word problems, and that's from the Google Classroom. So you have a document like this in the Google Classroom. You can see there are 12 word problems there. You can solve them any of the methods that I showed you in class, making tables, things like that. Yeah, Logan, we can start the docs. I know you asked for number 1 earlier and Kelsey asked for number 4. So let's look at number 1. Bring it over here. So here's number 1, and it says 1 inch. In 1 inch there are 2.54 centimeters. So right away, hey, there's a ratio, right? You see the ratio, 1 inch equals 2.54 centimeters. You can set it up as 1 over 2.54. Just keep in mind this is inches and this is centimeters. And that's going to equal something else. So we're going to continue reading. If a branch is 14 inches long, 14 inches, so again, think, is that inches or centimeters? I hope 14 inches is inches, so 14 goes on top with inches. You want to know how many centimeters long it is. You want to know this number here. So there's your x. And then you just solve for it. And when you solve, you can do cross products. So 1 times x gives you x. 2.45 times 14 gives you an ugly number. Gives you 34.3. And x is already by itself, so your answer is 34.3 centimeters. And if you think about that, just take a minute. You can think of 14 inches is a bit longer than a foot, and you know there's about 30 centimeters in a foot, so that's a bit longer than it. Makes sense. But yeah, that's one way of doing it. You could have also scaled that out. You could have been like, well, 1 inch is 2.54, so 2 inches is double that, which is going to be a pain to find and do it that way. You could have Well, it kind of already was in unit rate if you want to look at it as 2.54 over 1, and you want to multiply that by, what was it, 14? That'll give it to you if you want to do unit rate. So there are different ways to solve them. Pick whichever way you're comfortable with. I personally just set up proportions for everything, unless I can see it really easy off the top of my head. I want the layers. Do we have to show the work? I'm assuming the best you can. It is a typed document, so show as much as you can. It's the hard part is me being able to see it and interpret it on the computer and stuff, unlike you handwriting it. So if you get frustrated trying to find how to make different symbols and stuff, just best you can, Catherine. Okay, this is for Kelsey. Kelsey wanted number 4. This is number 4. If the scale distance is 3.5 inches on a map, represents an actual distance of 175 kilometers. What is the actual distance? Does the scale of a distance? What actual distance does a scale distance of 5.7 inches represent? So again, you're going to look at the first part here, and you're going to pick out your ratio. We have 3.5 inches to 175 kilometers. So you have 3.5, and again that's inches, over 175 kilometers. That's going to equal another fraction, and you have inches here, so inches is on top, 5.7, and you have your unknown here, which would be your answer. Yeah, if you want to use the asterisk for multiply and the backslash for divide, that's fine. Works the same in Excel, so we did do a little bit of that earlier in the year. But here, to solve, you're going to do cross products. So 5.7 times 175 is equal to 3.5 times x. 0.7 times 175. This gives me 997.5 equals 3.5x, and again do your algebra here. Divide by 3.5 to get x by itself. And you're getting 285 equals x. So x here is 285, and it's in kilometers. So don't forget your units on things. Is it x kilometers? Yeah, this is kilometers. So the way I set it up was the bottom was kilometers. Again, you can set these up. There's a ton of different ways to set these up. You could have set this up as 175 over 3.5 equals x over 5.7. That would have given you the same answer. You could have flipped things around like 3.5 equals 175 over 5.7 over x. That would have given you the same answer, and then the other one is, I guess, the reverse of that. Yeah, if you want to do it that way. It's all going to give you the same answer, so just as long as things are lining up, you should be all right. So any of the ones that people are confused on that I can help you through? But really, most of them you can solve with the proportion. Just set up the proportion and solve. Yeah, there is a way for things to not line up. For example, in that one, if I put 3.5 inches relates to I guess x over 175 and 5.7. That should not work. Just because this is inches, this will be kilometers, this will be kilometers, and this will be inches. You see how nothing really lines up? You end up multiplying kilometers by kilometers and inches by inches. And that's not what you want. So just pay attention to the context of things. 12. 12 says Shauna weighs 120 pounds. If 1 pound is approximately that many kilometers, so keep in mind this here is your actual first ratio. So the wording of this has to be is a little different because it gives you your original ratio here. So just reading it carefully, right? What is the ratio here? You have 1 pound. 1 pound for 45 kilograms. And yeah, things can't line up diagonally in some sense. Sometimes you only have like inches as units and it's a little tough to pick out, but you gotta sit there and read the problem to see how things line up. Again, if you pick out that first ratio, it sets everything up for you. So here, 1 pound is, that's actually 0.45 kilograms. Just read carefully. Right, and then this is going to set up the next one. You know, pounds has to be on top and kilograms has to be on the bottom. It's giving you 120 pounds, so 120 goes there and x goes there. Then you can solve, cross multiply. 0.45 times 120 is 54 equals x. And you're not doing division here because that's a 1. So you divide by 1, you're left with 54 equals x. So your answer here is kilograms because it goes with x. So your overall answer is 54 kilograms. Number 3. And yes, Logan, you know I have a dog. And he does bark. No, you're not going to meet him. Yeah, I left that one a little weird. You do not need to answer in full sentences, Eli. It's a review. I'm going to just grade it based on, hey, did you attempt these? I'm assuming if you're completely lost on something, you're asking a question. So I think it was Catherine and Gianna wanted number 3, so let's look at 3. So here's your shadow question, and I told you before with similar figures, that's how shadows work. They make similar figures. So a tree casts a shadow of 15 meters, while a 2-meter post nearby casts a shadow of 3 meters. So this here is actually your original relationship, or your original ratio. So you know that a 2-meter post casts a shadow of 3 meters. And here everything's in meters, so keep in mind that this is actual things and this is shadows. So just pay attention to context for when you line things up. And then a tree casts a shadow of 15 meters, and again, that's a shadow, so it goes with shadows. So 15 goes there. You don't know this one. And then you just cross multiply and solve. 2 times 15 gives you 30. 3 times x gives you 3x. Divide by 3, divide by 3, you get 10 equals x. And this is in meters. Everything here is in meters. So this is meters, this is meters. So your answer is going to be 10 meters. So your tree is 10 meters tall. Simple as that. Any other questions? Did I miss anything? Number 9. The docs I would like done by the test, which is Friday. So everything that I'm going to assign you this week, I'd like done by Friday. Let's see, this is number 9. Number 9 done the same way as everything else. A woman receives $110 for working 20 hours. There's your original ratio. That's dollars. That's hours. It's going to equal how many hours must she work? Well, that's in dollars, so dollars is on top. Over x, cross multiply. Solve for x, you get 110x equals 20 times 187 is 3740. Get x by itself, divide by 110. This cancels, leave you with x. And gives you 34. So your answer is 34, and that's in hours, because that's in hours. Science, I would like the projects, the test, and the key term quiz by Friday as well. That's what I would like to finish up. By Monday, I should have your next chapter unlocked. I got a couple more videos I need to make for that still. So hopefully before Monday, but by Monday, definitely. You'll start the astronomy. The astronomy one, I don't know. You can imagine 3 weeks from Monday, but everything is kind of still up in the air on things with school and stuff like that. This is number 2. Recipe calls for 4 cups of flour to 6 tablespoons of shortening. 4 cups to 6 tablespoons. 4 cups to 6 tablespoons. Tablespoons has a B in it. That's going to equal something that also has cups on top and tablespoons or whatever on the bottom. I don't know the abbreviation for tablespoons. How many tablespoons of shortening are needed for 6 cups of flour? 6 cups. So 6 goes there, x goes there. Cross multiply. 6 times 6 gives you 36. 4 times x gives you 4x. Divide each by 4. X equals 12. 12 tablespoons, or however you want to abbreviate tablespoons. Thanks, Logan. But yeah, that's number 2. You're saying x equals 9? X does equal 9. Sorry. 36 divided by 4 is 9. I did 36 divided by 3. It was 9. Sorry. Sorry, thanks, Eli. The girls' soccer team scored 60 points in 10 games. 60 points in 10 games. If they continue, how many points will they score in 15 games? So again, this is games. So games goes on the bottom here. And you want to solve for x. 60 times 15, 10 times x. Might be easier if you actually reduce this to 6 over 1 first and then did 6 times 15, which would give you 90. And then you wouldn't have to do the other part, but we'll do it the long way. 60 times 15 gives you 900, and that is equal to 10x, and then divide by 10. Divide by 10, knock the zeros off, you get 90 equals x, and that cancels. So this would be 90 points. When is the math docs due? I would like everything done by Friday. Honestly, you can probably do it today, would be the best, but your test is Friday. Everything else this week is going to be review for that test, just because there's a lot in this chapter and we started a lot of it before we got out of school, and then you had a week off in between, so I figured we're going to spend some time reviewing this week. So your first review was this little worksheet here, in just solving proportional problems. Again, you could have done this scaling wise in unit rate. Right, this one here, unit rate, probably would have been better. Right, 60 points in 10 games, which means you're doing 6 points in one game. 15 games, get 90. If you can't find 10 different types of rocks, I thought I asked you to do 12. But if you can't find 10 different types of rocks, find 10 rocks that look different. And maybe they might be the same. Do some research on the internet to see if you can identify them. But honestly, yeah, chances are, due to the fact that you're kind of stuck in one place right now, you might not be able to find 10 different types of rocks. Find 10 interesting looking rocks and then identify them. Some of them might be duplicates. And take a picture of it, because I don't know how else to look at it. So science by Friday, I want projects, key term quiz, and test for rocks done. So I want to be done with science on Friday. For math, we're reviewing this week, and you have a test Friday. Get your reviews done for Friday as well. So I want things by Friday. Yeah, Eli, I can explain that again. So they scored 60 points in 10 games, and I want to know 15 games worth of points. So what I did was I actually found unit rate doing that, because finding the unit rate to this equation is really simple, right? If I want the denominator to be 1, I just divide each by 10, which knocks off that 0, so my unit rate here is 6, right? 6 over 1. And then to get to 15 games, well, I just multiply 6 by 15. It gives me the 90. So in this case, solving the proportion ways was probably more difficult, but it is. So here you want it as a proportion with a denominator that is 15. So how do you go from 1 to 15? You multiply this by 15. To get your numerator, how do you go from 6 up? You have to multiply that by 15 as well, and that's what gives you your 90. But I don't really care about my numerator, I only care about my 90 for the question. Because I took it to the unit rate. It was the unit rate. So 60 over 10 as a unit rate with a denominator of 1 is 6 over 1. And then how many games did I want? I just multiplied the number of games I wanted by the unit rate, which is 15 times 6. This is number 8. 40-acre farm yields 600 bushels of wheat. 40 acres gives you 600 bushels. And I have no clue what the abbreviation for bushels are. How much weight would a 75-acre farm deal? So 75 would go there. And that's what you would want. Again, this might be easier to reduce before you do anything with, because you can divide each by 10 and get rid of the 0. That way you have 60 times 75 equals 4x. 60 times 75 gives you 4500 equals 4x. Divide that by 4, divide this by 4. Should be getting 1,000 equals x, which makes sense because you're almost doubling this. So if you doubled the 600, then it would be about 1,200. So 1125 bushels. And it looks like we're just going to be doing all of these in no particular order. Number 7. 3 tickets. It's $13.20. How much would 7 tickets cost? 7 tickets on top. Solve for X. You want me to continue going with the solving of it? I mean, they're all solved the same way. 7 times 1320 is equal to 3 times X. 7 times 1320 gives me 92.4 equals 3x. Divide by 3, divide by 3. Gives you $30.80. Keep in mind this is money. It costs $3.80 for 7 tickets. That was 7. Next up is 11, then 8 again. Okay. Why do I keep doing that? I mean, math class is technically over. I mean, we end at 2. It's 2:06. If you want to get off, you can, but I'll go and do number 8 again too if you want. I'm not too picky. If you want the help, I'll give you the help. If you're willing to stick around for it. To make concrete, a person mixes 1 bag of cement, 4 bags of sand. So 1 bag of cement, 4 bags of sand. Just watch your units because everything is measured in bags here. So 1 bag to 4 bags, and this is your cement, and this is your sand. Just keep that in mind. You have 100 bags of sand. Well, you have sand. So 100 goes here for sand. Unknown goes there for cement. And then you solve. 1 times 100 is 100. 4 times x is 4x. Divide each by 4. 25 equals x, so 25 bags of cement. Because again, that's cement. I can do number 8. I'll do number 8 if no one else has anything else they want to do. But this was 11. So again, original ratio here is 40 acres for 600 bushels, so 40 over 600. And keep in mind this is acres and this is bushels. And we have 75 acres, so it goes with acres on top, which is 75. And then you have x. Again, when I do this, I don't want to deal with the big number, so I can reduce this fraction before I start. So what I'm going to do is I'm going to reduce it by 10, and I'm going to get 4 over 60 equals 75 over x. That way it's a little easier for me to work with number-wise. So 60 times 75, again, equals 4,500, and then 4 times x gives you 4x. Divide that by 4, divide that by 4. And you get 1125 equals x. Again, that's going to cancel. This is bushels. I don't think we did 10, but I can do 10. And then I'll do 3 and 6 if you need, Sarah. Oh, this is 10. In a certain school, there are 4 girls for every 5 boys. So 4 girls, 5 boys. And there are, this is girls, so it goes with girls, 560 girls, 2 X boys. Again, that's a B for boys. So 5 times 560, 4 times X. Yeah, you could graph them if you want, but I mean, you got to find 2 points, Eli. Graphing normally comes in play when you want to know multiple ratios of equivalent ratios, because it gives you every single possible answer to equivalent ratios. So multiply 5 times 560, you get that. 4 times X is that. Divide by 4, divide by 4. You get what? 700 equals X. So there are 700 boys. See, Sarah asked for a 3 again. So 3. Again, just keep in mind which one's shadows and which ones are actual objects. So a tree casts a shadow 15 meters. So I mean, you could, one way to look at it is, hey, you have the tree on top and 15-meter shadow on the bottom, if you want to do it that way. And then your next one is a 2-meter post casts a shadow of 3 meters. So the post is 2-meter post and a 3-meter shadow. Or you could use this as your original ratio, so 2 to 3 equals X over 15. Either way, it's the same math. You're going to do 2 times 15, right? 2 times 15, which gives you 30. Then you're going to do X times 3. X times 3 equals 3X. Get X by itself. That cancels, leaves you with X. And that leaves you 10, so it is 10 meters. This is 6. Train travels 90 miles in 1.5 hours. 90 miles, 1.5 hours. This gives you hours. Hours are on bottom, miles are on top. You want 6 and X. Cross multiply to solve. 90 times 6. 540. 1.5 times X is 1.5X. Get X by itself by dividing each side by 1.5. 540 divided by 1.5 gives you 360 equals X. So your answer is 360 miles. do 7 again. Let's see, people are working at their own rates. That's fine. It's 7. I put that in the wrong. That's alright. Seven. 3 tickets to the show costs $13.20. So 3 tickets for $13.20. There's Fletcher units. This is tickets. This is money. 7 is tickets. So I don't know that. So that's all for X. Yeah, Eli, if you understand it, you can leave again. Class was over 16 minutes ago. I just like the sheet by Friday. If you have other questions, you can email me, or you can review this hour-long live stream. So with that, I am going to end it because I'm getting tired of talking here. I mean, if you have questions on any specific one, you can email me. I'll make you a quick video explaining how to do it and email you back with it. So with that, have a good day. Go outside. Stay away from other people, though.